The ZTransform is an important signal processing tool for analyzing the interaction between signals and systems. The communication branches rely on discrete analysis. The main difference of ZTransforms or the Laplace transforms is ZTransforms operate not on functions of continuous arguments, but it is operate on sequence of the discrete integer valued arguments. The ZTransform is a very much useful and important technique in the areas of signal processing, system design and analysis, control theory. So what is the basic definition of a ZTransform of a sequence? Let un be the sequence defined for discrete values n vary from 0, 1, 2, 3 and so on. Then the ZTransform of sequence un is denoted by ZTransform of un, and it is defined as ZTransform of un is sigma n is equal to 0 to infinity un z power negative n, that equals to u of z. What is the linearity property? Let un vn be two discrete sequences, then ZTransform of a times of un plus b times of vn is equals to a times of ZTransform of un plus b times of ZTransform of vn, where a and b are constants. Now we can see change of scale property or a damping rule. Let un be any discrete sequence and ZTransform of un is u of z, then ZTransform of a power negative n un is u of az. The second damping rule is ZTransform of a power n un is u of z by a. Now let us see some standard ZTransforms. Find ZTransform so that ZTransform of an equals to z by z minus a, where n is non-negative. By the definition, we have ZTransform of an is sigma n is equal to 0 to infinity an z power negative n. A power n z power negative n, a by z whole power n. Now expand this series. When n is equal to 0, a by z power 0 is 1. When n is equal to 1, we have the second term a by z. When n equals to 2, we have the third term a by z whole square. When n is equals to 3, we have a by z power 3 and so on. One can observe that it is a sum of infinite terms of a geometric progression. We know that the sum of infinite terms of a geometric progression, a by 1 negative r, a is the first term, r is the common ratio. According to it, we have 1 by 1 negative a by z, where a is 1, r is a by z. On simplification, we obtain z by z negative a. Hence, ZTransform of an is z by z negative a. Let us see some particular cases. ZTransform of 1, that is ZTransform of 1 power n z by z negative 1. So where we have a, that a is directly replaced with 1, we obtain ZTransform of 1 as z by z minus 1. ZTransform of k is kz by z minus 1, where k is constant. Now you can see another important result on ZTransform of n power p, where p is natural number. Its result, ZTransform of n power p equals to negative z d by dz of ZTransform of n power p negative 1. Now we can show that ZTransform of n is z by z negative 1 whole squared. In the above result, taking p is equal to 1, we get ZTransform of n equals to negative z first derivative to the ZTransform of, and p is equal to 1, 1 negative 1 0, n anything over 0 is only 1. We know that ZTransform of 1 z by z minus 1 negative z We know that d by dz of uv, vu dash minus uv dash by v square, according to it v z negative 1, v square means z negative 1 whole squared, v z negative 1, z derivative 1, negative u z v dash is 1, so it is a numerator. On simplification we have obtained z by z negative 1 whole squared. Hence Z transform of n is z by z minus 1 whole squared. Now you can see Z transform of n square, z square plus z by z negative 1 power 3. Z transform of n power 3, z cube plus 4z square plus z by z negative 1 power 4. And remember all these formulae for getting Z transforms of various discrete functions. Z transform of cosine n theta, z times of z negative cos theta upon z square negative 2z cos theta plus 1. Z transform of sin n theta, z sin theta by z square negative 2z cos theta plus 1. Z transform of cosine h n theta, z times of z negative cosine h theta whole by z square negative 2z cosine h theta plus 1. Z transform of sin h n theta, z sin h theta upon z square negative 2z cosine h theta plus 1. Shifting theorems on Z transforms. If Z transform of un equals to u of z, then Z transform of un plus k is z power k times of u of z negative u0 negative u1 z power negative 1 u2 z power negative 2, proceeding in this way negative uk minus 1 z power negative of k negative 1 occur. It is called left shifting theorem. Coming to right shifting theorem, if Z transform of un is u of z, then Z transform of un negative k is z power negative k u of z, provided that n is more than k. Initial value theorem. If Z transform of un is u of z, then u naught limit z tend to infinity u of z, the initial point which is obtained when z approaches infinity. Similarly, one can see u1 limit z tend to infinity z times of uz negative u naught, u2 limit z tend to infinity z square times uz negative u naught, u1 z power negative 1. u3 is limit z tend to infinity z power 3 uz negative u naught negative u1 z power negative 1 negative u2 z power negative 2. And remember all these formulae to get u0, u1, u2 and u3. And we will discuss final value theorem. Limit as n tend to infinity un is limit z tend to 1 z negative 1 u of z. To get the limit for un as n tend to infinity, we will define the limit at z tend to 1.